friends and family members of Dr. Sumit Ray. And
Yeah.
just for students actually who have joined, I just like to brief a few things. Obviously, Professor Chattopadhyay will be saying a lot of things on his life and works and research works, his contributions in the field of structural geology and tectonics, and especially in India. But just for students, I'd like to say a few words that Dr. Sumit Ray was born in 1945 and he did his BSc and MSc from Jadavpur University, followed by a PhD from IIT Kharagpur with Professor Khitin Naha. And his MSc supervisor was Professor Sumit Kumar Ghosh. So he became like his supervisors in time, and he also contributed a lot towards the understanding of the large scale tectonics as well as a small scale structure in various parts of the India. He has worked for several years in the Geological Survey of India and finally retired as the Deputy Director General. He was also nominated and elected finally as the Fellow of the National Academy of Sciences India, also Fellow of the World Academy of Science and Technology. So just to mention the wide spectrum of his research, for students, they should know that he has worked in the Khetri copper belt of Rajasthan. His famous work on the albitite line and associated uranium and other ore zones. Also, he has worked in detail on the geodynamics of the Northeast India, especially geological and ecological impact in the northern Andaman Islands after the 2004 earthquake and tsunami. So you can see a wide spectrum of geological research. Also, he did a lot of work on the tectonics of the Sumar Alakthon in Bhutan, and also on the understanding of the overall thrust tectonics in the Himalayan region. Also, he has actually did a lot of work and mentored many students to look into shear zones rocks, especially pseudotachelites. And also, he has worked during his MSc PhD days. He also worked on the evolution of the Shimla clippet. So, before inviting Anupam sir, I would urge all the members of this community to keep or to maintain a 1 minute silence before the lecture, and there will be no question answer session after the lecture today. Thank you all for maintaining the 1 minute silence, and may the Almighty give strength to His near and dear ones to bear this loss. Now, I'd like to formally invite Professor Anupam Chattopadhyay. Today, he will be delivering a talk on the works and research contributions of Dr. Sumit Kumar Ray. Welcome, sir.
Thank you, Shandeep. Thank you, Shantanu, for inviting me to talk on this topic. It's not a pleasant job to talk on the contribution of Sumit Da, because he was closely, I knew him quite closely and have worked with him, have followed his work for a long time. So I'll try to briefly summarize what he has contributed, how deeply he has impacted structural geology in India. and it will be not a formal lecture, just a kind of reminiscence in different parts. So I'll just, if you allow me, I'll just share some presentation that will help me in.
Yes, sir. So you can now share, sir.
Yeah. Can you see this presentation?
Yes, sir. Yeah.
Is it visible?
Yes, sir. Yeah.
Yes, it is visible. Yes.
So today's my topic of talking is remembering Dr. Sumit Kumar Ray through his research contributions. So as has been already told by Sayandeep and Shantanu, Sumita has been our ex-student of Jadavpur University. So I personally knew him from my MSc dissertation days when I used to work in Professor S.K. Ghosh's lab, Subir Kumar Ghosh's lab, working on analog modeling of thrust tectonics, which later I continued in my PhD along with under guidance of Professor Ghosh as well as Nibir Mondal. And we then when we used to do this kind of thing, he often visited the lab during his leisure time or after the office, and many a times used to discuss with us what thrust tectonics are really about in the Himalayas. So that reminds me of a lot of interaction with this very intelligent and scientifically oriented person from my young days. So today, looking back at his contribution later in the GSI, Geological Survey of India, when I joined Geological Survey of India, initial years I was not working with him, but during my Calcutta posting days in early 2000, 1999, 2000, 2001, I have seen him a lot and discussed a lot of things with him. And that continued even when I left GSI and joined Delhi University. So just to looking back at his research contributions, I would say that he was a structural geologist par excellence who contributed significantly to both the academia and the industrial landscape of India. Industry means the mineral industry of India, through his insightful research work. His work can be divided roughly into three categories. I have divided in that way. One is the systematic mapping, kinematic analysis, and tectonic modeling of regional scale structures. That is the field-based, large-scale field-based work, which mostly he has done on the Shimla area, Shimla Klippe, in the Bhutan Himalayas, Shumar Alakhan, and in the eastern Himalayas, in the Rangit Window and the Lingsen Ice. These are his major contributions from the main Himalayan ranges. Also, he has some work in the northeast. The structural modeling of important ore-bearing zones with emphasis on structural control of the mineralization. Like as Shandeep mentioned, it is the albitite line of Rajasthan between Khetri and Kishangarh. It's a very long line with unusual exposure of albite-rich rocks, the albitites and the albitite-magnetite combined. And then the Saladipura lead zinc deposit in Rajasthan, addressing, and the third part is the addressing the fundamental research issues in structural geology, which of course he conducted when he was working in different terrains from the Geological Survey of India, but there his research focused on particular processes, not only the area, the geological history or of the particular area. So this includes frictional melting and melt class interaction in pseudotachelites and other fault-related rocks, and then the nonlinear thrust traces in the topology of thrust surface and thrust surfaces, which he mostly highlighted from the Shumar Alakhan in the Bhutan Himalayan area, and the inversion of fold hinges by rotation during superposed folding. This he did from the Sawar inlier, a small outcrop. Small means a few kilometers outcrop of folded rocks in Sawar area of Rajasthan. So apart from this, he has investigated the land upheaval and subsidence his records and in plant mortality, etc., in the different parts of Andaman Islands after the Great Indian Ocean Tsunami of 2004, and he elucidated on the rotational movement of possible rotational movement of the subduction zone thrust along the Java Sumatra Trench. So these are his major areas of work. I will briefly summarize each of them. So coming to the regional structure and tectonic modeling, in the Simla area, this is his PhD area actually, when he worked with Professor Kitindra Mohan Naha in IIT Kharagpur. Of course, he was partly at that time also working in Geological Survey, I believe. So this work published in very good journals at that time. Contribution to mineralogy and petrology, I have given the references: Naha and Roy, 1970, contribution to mineralogy, petrology, 1971 American Journal of Science, and 1972 Geol Runshaw. There, they showed that the metamorphosed sedimentary rocks of like mica schist or quartzite, marble, etc., that units of the Jutok series, they show three phases of folding, and these are structurally overlying, or is just above the phyllite quartzite units of the Chell series, and they are separated by the Jutok thrust. So it was the whole Jutok series was thrusted over the Chell series, and this forms the Shimla Clippe. Now the first phase of recumbent reclined folds, that is the F1 folds of the Jutok series, they are absent in the Chell series, that they have demonstrated through detailed field mapping. And whereas the later F2, F3 folds and the later part of the structural history is shared by both type of rocks. So they interpreted that the thrusting took place. And also another important thing is the post F1 albite tepido-tankibolite facies metamorphism of the Jutok series is also absent in the Chell series. But the later post F2 greenschist facies metamorphism is observed in both. So they interpreted that the thrust is post F1 but pre F2 or early scene F2. This work systematically recorded the structural and metamorphic evolution of the Shimla Klippen. And another important thing is this: they contradicted or rejected the idea, earlier interpretation of a large scale fold knob. They modeled this as a huge thrust sheet rather than a large scale recumbent fold knob, which was earlier proposed by Pilgrim and West in the line of some of the alpine fold knobs. So this was one of the major modern tectonic interpretation and work in those days in the Shimla Himalayas. And you can see that I have just put in one or two images from his paper. So they are not very clearly seen here, but you can see the kind of map that he produced, a very systematic mapping. Maybe part of the map has been taken from other earlier existing maps also, it may be slightly modified, I do not know, but at least the amount of data that he has put in, that is amazing. And you can see the cross section of the knob, of the thrust sheet, the Jutok series, the underlying Chell series, and the Jutok thrust, all these things in the cross section. That is so beautiful. Now, in the second part, the second major work in Bhutan, which he published in another very top level journals, two in Tectonophysics, one in Journal of Structural Geology in 1990s, 89, 91, 95. In a series of papers, he showed that the lesser Himalayas of the Bhutan comprises a series of thin thrust sheets. The topmost one is the Shumar Alakthon, which comprises an imbricate sequence of horses forming a hinterland dipping duplex in the lower part of the Shumar thrust, where the Shumar thrust cuts the underlying Baksa group along a transverse footwall ramp and then rejoins the root thrust above. And more interestingly, from here, not only the beautiful map that you can see, which I have clicked from his papers, a very detailed, beautiful map with a lot of data, which he had produced, not only, maybe not he only by himself, but by a team of geologists of Geological Survey of India, but he was the leader. And the kind of map that they have produced, both structural as well as lithological, it is just amazing. And another very important thing that he took from this particular area and discussed at length in his other papers, all these papers and also in some other papers, is the thrust sheet dimension, the shape of the thrust surfaces, or the topology of the thrust surfaces. And he suggested that these are not, thrust surfaces are known to be listric, that is in the longitudinal section. If you say transport parallel sections, they are carved like a shovel, that we know. But what he suggested is that they are not only listric in the transport direction, but also in the laterally they are also carved. So they are like something like a spatulate in 3 dimension. and that is why the thrust surfaces are like cusps and lobes, and he interpreted it as by joining of thrust, smaller thrusts from nucleating at laterally at different points. I will elaborate on that in another slide when I discuss the fundamental structural issues. But here the Bhutan, the Shumar Alakthon map and the general geology of the Bhutan Himalayas, the structural Himalayas, structural history was very much detailed. He unraveled, and he also showed that the forelimb of the large scale Shumar Alakthon is intricately folded and thickened, whereas the back limb is thinned and stretched. That is, he explained that by fold and directed simple shear, so that the already asymmetric folds of the Shumar Alakthon, their longer limbs are stretched because they are in the parallel to the shear direction, whereas the shorter limbs, they are at an angle with the in an antithetic way in the Shumar with the southward shear direction, top to the south shear direction, and so they got intricately folded. So that was another structural contribution from this area. And he also showed plunging fault propagation folds in the Shumar Alakthon, which he published in a book in honor of Professor Ghosh and Naha, edited by Professor Sudipta Sengupta. So this is his contribution from the Shumar Alakthon. I will come back to this. Now going to the structurally controlled ore mineralization, here he has mostly worked as a GSI geologist, mostly publishing in GSI reports and a few papers in Journal of Geological Society of India and Indian Journal of Geoscience, where he showed that the 170 kilometer, one is on the albitite line of Rajasthan, where 170 kilometer long north-northeast south-southwest trending line between Khetri and Kishangarh, which exposes albitite, magnetite, albitite and pyroxenite, along with ores of copper, molybdenum, uranium, gold, Re, and magnetite, ilmenite and fluorite. So these ore potentials have been discussed in detail by him in several papers, directing giving a new ideas to the GSI and the exploration agencies to look for these kind of metals and Res along this line. And he also explained that this represents different cumulate portions of the same magma chamber at depth, and then deep fractures trending parallel to the structural trend of the Delhi fold bed represents an ancient rift system that tapped the underlying magma reservoir. So the albitite rocks at the surface, they are actually all linear. So they explain them to be emplaced along the rift-related large fault systems. And again, in the Saladipura deposit of Rajasthan, he showed it is in the southern part of the it hosts a very massive pyrite pyrrhotite deposit. So there he worked, and he showed that the rocks are basically primary syngenetic ore, which is later reworked and partly immobilized during the host of deformation. The ore body is stratabound and shows all the deformation features of the host rock, and they show upright to inclined F1 folds, the Delhi supergroups, and the ore body also shows the same kind of features. So he interpreted that these are all same deformational movements of the ore, but the ore was originally sedimentary or primary syngenetic in nature. So there is not much to discuss about this. So I am going to the next section, which is fundamental structural issues. This is one of his biggest contribution, I would say, from the Geological Survey of India. Very few people have contributed so deeply to fundamental science. So this is where Dr. Sumit Ray was unique, because he was very much at ease with academic as well as industrial issues. So I will just highlight three major contributions. One is the folding inversion by rotation during superposed deformation. This he has published in one early paper in Picambian Research 1974, and followed by another paper in Journal of Structural Geology in 2018, which by stroke of luck I reviewed. He didn't know, but I reviewed this paper, and it was an excellent thinking, not that it is something very complicated, but it is a very nice thinking. That is the signature of a very good scientist. You see, what he showed basically is that this Sawar area, this is an I-shaped structure in the within the BGC, in the somewhere east of Ajmer. So here it shows an antiformal closure, along the same axial trace as a synformal closure. So basically this portion, I don't know whether you can see this point, just a minute. So this portion, this shows a, you can see from here that this shows an synformal closure, and along the same large scale fold axial plane, here you see an antiformal closure. So that means there is a hinge plunge inversion. So it is not only doubly plunging, because what happens in case of doubly plunging or plunge reversal is that the trend of the direction of plunge changes, but the plunge is not so much, the plunge doesn't change so much so that they become, a synform becomes completely an antiform. So that is what he showed in this area, and he said that during superposed, earlier there was an early synform, during superposed folding of the synform, type 1 folding kind of, type 1 plain non-cylindrical type fold initiated, where the earlier hinge line was carved and part of the hinge segments they rotate, and they rotated unequally, and one part rotated through the limiting angle to plunge in the same direction as the other part, which leads to plunge inversion, and an antiform synform shares a common axial trace. So here another thing is that during the later part of the superposed folding, you can see that the fold has become slightly non-cylindrical also. So apparently it's a non-cylindrical non-planar fold, the final product, but initially it started as a plain non-cylindrical fold, and that's why that he has explained through a number of his models. So you can see that he gives this type of a block diagram. So now this is the shower structure. One side is the synform plunging towards southwest, and another part, the other side, this side is basically antiform, an antiform which is very steep, but steeply plunging towards the same direction. So here this is the model, and he explained this by this kind of a model, taking an early synform and then rotating them unequally, and that shows that the fold hinge, the one part of the hinge will rotate through a critical angle to become an antiform, whereas the other part remains the same, that is as a synform, and thus the axial plane will be shared by the two this thing. So it is in a way a mega sheath, but it has formed not by the typical sheath folding model of shearing, but by superposed this type 1 superposed deformation. And the plane of symmetry of this kind of a fold, actually in this model they show a certain dip that is inclined, whereas if there is an equal rotation, then he argued that this plane will be much steeper and will not have a very distinct strike and dip towards one side. So this is the fold in hinge inversion work by Dr. Roy. Now another issue that he came up with is the shape of the thrust surface. Actually this goes back to the Schumann allochthon where he mapped, and he showed that if you take a lateral cross section, that is transport direction perpendicular cross section, so in the sense of Himalayas it is an east-west cross section, you can see that then basically you are facing the transport direction. And here, as we know that in the transport parallel direction the fault planes are carved or streaked, but here even in the transport perpendicular section you can see that the Schumann thrust has number of cusps and this kind of lobes. So they are fluted structure, which he demonstrated by this kind of a diagram, and he showed that the thrust surfaces are spatulate, and these are not only ideas, he has demonstrated this from the field data that they are spatulate, and that's why the thrust when it cuts the surface, that is not only because of the topography, but even on a flatter surface they will carve out sinuous traces. So he actually collated a number of sinuous thrust traces from different parts of the Himalaya. Actually, here from taking from his work, the idea taken from his work, I conducted in my own lab here in the university a series of experiments and published one paper much later in Journal of Structural Geology in 2014, where we saw that yes, there are certainly sinuous thrust traces, and wherever there is a recess salient, then there are salients and recesses. So where there is a recess, there will be another salient in front of that, and vice versa. So there will be something like an inward curvature followed by an outward curvature of the next thrust. And if you see a transport perpendicular section in the model, because in the model it is much easier to show, so we could see that the thrust surfaces which are indicated here, they are actually curved and wavy. So they are in a way correctly predicted that they are spatulate and in 3 dimensions, because in the transport parallel direction also they are listed. So they are like fluted surfaces, as Dr. Ray correctly predicted from the field data. And that's why we also thought that thrust surfaces will look something like this, and we analyze this as a self-affine. The thrust shapes are self-affine fractals, and these are also not only from the Himalayas, even very young compressional zones, like say this is the submarine Nankai Trough wedge, where we saw that these images, they show very clear sinuous lines of thrust lines, where the accretionary wedges are showing the exposure of thrust from a more or less flat seabed. So the contribution of Dr. Sumit Ray in this particular line is also very fundamental, I would say. Now coming to the third and the last one, this is another very, very impactful work by Dr. Sumit Ray, which is cited almost by everyone all over the world who works on pseudotachylites. This is another line of research where my interest overlaps with his for a long time. So he published 2 very important papers, seminal contributions in Tectonophysics 1999 and Journal of Structure 2004, where he showed that this was also shown by some others earlier also, like Nagahama and others, then Tsutsumi, that in pseudotachylite, what happens is basically it's a rock which is initially crushed by faulting, but later due to the frictional heat, accumulating along the thrust surface, the rock gets partially melted, and mostly the mafic rock minerals melt, and they create a more mafic melt, and that melt pervades the crushed rock, fragments, and that gives rise to a very unusual kind of grain size distribution, because we know that in cataclasis there is a lot of work in material science as well as in structural geology, that if a rock is crushed or cataclasis takes place, then normally there is a log normal distribution of this power law distribution of grain size. That means the relic class there will be as we go towards the less and less size of the class, they will be increasing more and more in number in a non-linear way. So if we plot them in a log-log graph, then they should show a straight line, and that is ideally ideal cataclastic behavior. But when these things are tested with pseudotachylites, then it is found that although in the coarser part they follow mostly the cataclastic type power law behavior, but when it comes to very small clasts, then there suddenly is a large deviation from the predicted distribution, power law distribution, and that is also shown by Dr. Ray from his own work. And there the interpretation is that the smaller grains, due to the melting, the smaller grains preferentially vanish from the system, so they melt out completely, and so there is a dearth of the number of smaller grains with respect to the larger grains. So this ideal straight line behavior is deviated. And to explain this, Dr. Sumit Ray, in his second paper in 2004, Journal of Structural paper, he showed one numerical model. He prepared a numerical model where he showed that if there is a uniform, we assume that there is a uniform melting along rims of all clasts, then if the clast is smaller than a critical size, then the total melt will completely reach the core of the fragment, so that that particular size clasts are all melted, totally melted out, and that creates a large deviation in the number of small clasts, as is shown in this figure. So he explained this by numerical modeling, and this is considered as a conclusive evidence of melt origin of pseudotachylite, because the crushing origin, even if you crush them by all kinds of cataclastic behavior, it cannot actually explain this kind of left-hand deviation. So Ray in 2004 proposed that a power law class size distribution is produced by cataclasis, which is followed by invasion of frictional melt that leads to a uniform remelting, total removal of final clasts, and produce a modified class size distribution in pseudotachylite, which is now observed. So his contribution was mostly from the field-based work, whereas the Japanese group, that is Nagahama and Shimamoto and then Tsutsumi and others, they actually showed them from the experimentally produced, lab-produced pseudotachylite, melting of pseudotachylites. But however, while working on this from the field samples, my research group, we partly contradicted the idea of uniform rim melting, because we saw that the class size distribution of a typical cataclasite, fault cataclasite from the field, it is a bifractal. There are clearly two different fractal dimensions, and they cannot produce this kind of a smooth transition from one type to left-hand deviation only for the smaller clasts. So that is not possible by modification of the class size distribution of cataclasites. So and we also argued that all clasts do not melt uniformly. Other small clasts melt to a different extent, different clasts melt to a different extent depending on their size, position within the vein, and the residence time in the melt. That is how much time the clast melt interaction is going on. And this is one of our figures. You can see here from the left that here you can see that this red line and the black line, they represent clasts from the boundary, that is the relatively colder portion of pseudotachylite, whereas the central part, which is hotter, that is shown by the red line. So here you can see that smaller clasts are surviving more in the colder zone than the hotter zone. So that indicates that there is a differential nature of melting. Uniform beam melting may not be the solution. But anyway, his contribution overall has a very, very deep impact on the grain size distribution of pseudotachylite and cataclasites, and it is very, very well cited all over the world. Now the last but not the least, the vertical land uplift and subsidence of Andaman Islands after the 2004 MW 9.2 earthquake and tsunami in the Indonesia, Java, Andaman area. There are a series of reports. Basically, these are mostly reports by Ray, led by S.K. Ray and Acharya GSI report, and then Ray and Acharya in Current Science. There was a paper in 2011. I think on this, Sumit gave a talk in the last RDS also. So here you can see that what they are suggesting is that when they see the tree line, so they see that there are slow plant mortality at different, as we go from the earlier C strand to the lesser one. So you can see Ray and Acharya thoroughly recorded the upheaval and subsidence of land and the resulting rise in high tide level along various beaches and wetlands. So they reported land subsidence in South Andaman and upheaval in North Andaman. You can see that these are the lines of bathymetric lines. So you can see the plus means there is a uprise and the minus means there is a subsidence. So you see the more subsidence has been reported from the eastern side and mostly in the southern and South Andaman Islands, whereas in the North Andaman Islands there is a lot of upliftment. So this is confirmed by the gradual upliftment in the North Andaman is confirmed by observing slow mortality of mangrove forest along the upper part of the marshland. So they suggested from this figure also you can see that where the land is slowly uprising after, during or post tsunami, then the mangrove forests which were originally very lush and very dense, they are slowly dying a death because they are going above the possible marshy, salty marshy line, because that is the environment where mangrove thrives. So they are going out of that environment and they are slowly dying. So that thing they have very thoroughly they have shown in the northern islands. And also he tried to interpret that this kind of subsidence in the southeast and upheaval or the tectonic uplift in the north and northwestern part is because the thrust, the subduction zone thrust block. This is on the obviously on the hanging wall block. So the thrust movement was not really deep sleep, it was slightly oblique with slight kind of rotational movement, so that the northern side has been uplifted more and the southern side has gone slightly down. So that is the reason why all these features from the topography to tide line gauges also they have examined, and also this bank mortality, all these things combined together. This gives a clear idea about the possible nature of oblique and rotational movement of the thrust plane. So that was another contribution that he has made in the last phase of his work in Andamans, just before or around the time of his retirement. So that's all. This is my personal reminiscence. This in chairing some session in BHU RDS 2022. This is the middle photograph in a field in GSI Training Institute, along with another GSI colleague. We were on the Zawar Hills, and here another pleasant evening in the Renuput, where Sumit was explaining to all of us how good idli he makes in the evening, and Dr. Abhinav was teasing him with some sarcastic comments, and there was a lot of fun and laughter. So those were really halcyon days, which we are right now very much missing. Both of them are, one has left us, another is in very bad shape physically. Sumit giving a talk in RDS, last RDS. So that's all. Rest in peace, Sumit. Thank you very much.
Thank you, Anupam. We thank Professor Anupam Chattopadhyay for covering almost entire thing that Sumit has contributed to geoscience as a whole. So now I know there are many people are there, so everybody has something to say there. Before we start that, I will request Dr. Rajashri Ray, son of Sumit, if you are still here. Rajashri, are you here?
Yes, I am here.
So, if you want to say something to the community that he belonged, and we really miss him, So we want to hear.
We don't have much to say. Just many thanks to the SGTSGI community for organizing this memorial meeting, and thanks to Professor Chattopadhyay for briefly summarizing the works of Dr. Ray. So we heard, he used to discuss his work sometimes with us. We didn't used to understand them, but it was still a joy listening to his works, sharing his work with us within the family. So it was great to listen again from Professor Chattopadhyay on his contributions. That's all. Thank you very much for this meeting.
Okay. And I think Dr. Ashim Kumar, I don't know the title, he has raised his hand to talk something. Before I ask you, Dr. Ashim Babu, I will. There is Professor Dilip Mukhopadhyay is there, who had a long stay with Dr. Sumit Ray since his doctoral life. So I would request Professor Dilip Mukhopadhyay to speak something of his association with Dr. Ray.
Well, thank you, Shantanu. Dr. Sumit Kumar Ray Sumita, to many of us here, will be sorely missed by the structural community. He was possibly the most favorite student of Professor K. Naha. May I add that I was probably the second most favorite student of Professor Naha. So I heard many anecdotes uh, about Sumit Ray as a student when they were doing field work in Simla. One that I remember very vividly, he said that it was very cold and they would stay in those days, in some dharamsala or some place like that. No luxuries resorts that time. So quite often, Sumit would go out of the room. They're staying in the same room, and then will return after some time, a few minutes. Then Professor Naha told him, Sumit, you can smoke inside the room. You don't have to go and catch cold outside. So this I heard from Professor Naha. He was my Guru Bhai. Sumit was my Guru Bhai. Because we both did PhD with Professor Naha. It's a personal great loss for me, personally. Not that I would often meet him because distance was quite substantial. But we discussed wherever we met, we discussed and things like that. Sumit, in his PhD work, he did map, as Anupam showed us, he mapped in detail with a lot of structural data in the Himalayas. The first project that I think, the first worker that I think, who did detailed structural work, structural analysis. Before that, I cannot remember anybody who had done this detailed structural work and structural analysis. So much so that the Dean of Himalayan Geology, Lefort, Patrick Lefort, he wrote in his paper, there are plethora of, I don't remember exact sentence right now, there are plethora of thrust surfaces proposed in the Himalayas, rarely, if ever, and within bracket, Naha and Sumit Ray, who shows that why a thrust is called a thrust. And that has not really changed much to this day. We say there is a thrust here, thrust there, thrust there, thrust there, but rarely we show evidence of each of those thrusts. So it was in similar clipping as Anupam has described, and it was a fantastic kind of work. This led to my first project in the Himalayas in the adjacent Chur area, adjacent to Simla Hills. And it was primarily because such an excellent map was already prepared in the Simla area. Not to forget, of course, the contributions of the British era geologists. So that paper, that work, led me to Himalayas and look at thrust tectonics. And may I add that my student who was working in Chur area, and later on, in particular, Premanand Mishra, who was working on section balancing, he used to be ridiculed by a few people, not in front of me, but others, that structural modeling experiment work, they do not really justify this section balancing. Then I said, wait, Premananda, someday somebody will have an experimental work to prove that fault propagation fold and such structural models are valid really, experimentally also. But all this work was primarily an extension of Professor Sumit Ray or Sumit, his work in the Simla Hills. Later on, when I was working in Sikkim Hills, then there are a lot of people who made their life's contribution based on the concept of buried duplex. It was Sumit Ray for the first time who showed that there is a buried duplex. It was Sumit Ray, our beloved Sumit. But very few people ever talk about that particular paper. It was published by GSI, but it was the first ever. So the concept of buried duplex in the Himalayas, and that can lead to the mat pattern, was first contribution by Sumit Ray in the Himalayas, whole of Himalayas. But many of us will try to ignore that contribution. Only thing that I finally would like to say is that a friend's departure is very painful. Because if nothing else, that you lose a friend is itself a very painful thing. But also, it is a reminder who knows who's the next. I have reached an age where such thoughts sometimes occur. So Sumita, wherever you are, be peaceful, which he was always, and your soul may rest in peace. Thank you. Thank you, whoever is coordinating.
Yes, Shantanu.
Shantanu, are you here?
Hello.
Shantanu, please take over.
I think
Shanti will take over.
there is so some network problem with us. Okay, so I now invite Neptune sir to share his views or memories.
Yeah, thank you, Sayandeep. Every year when I come to India, we make a point. Sumit and I used to make a point to meet. And this year, when I was, and in the Salt Lake, he used to live like 2 blocks from my house. So, it was kind of walking distance. So I was going there. It was evening. I thought I'll give a call. I called, no one picked up. I called again, no one picked up. Then I sent a message, says, hey, this is Neptune. And then Sumit's wife, Bodhi, she called back and she said that Sumit is in such a bad shape. It's advanced stage of cancer. The kids are coming from foreign countries and they have to decide what to do. He has a hard time talking. So I said, I felt so devastated. I almost felt like sitting down on the road itself. I mean, it was totally unexpected, like what we call a bolt from the blue. But then Sumit, when he heard that I was there, he wanted to talk to me with a great difficulty. We discussed. I said, look, Sumit, as Dilip just mentioned, we already have 1 feet across the threshold. The process has started. But at least we had a, creative life. We are fulfilled, and at least, till the last day, our brain should be working. That's, we should not cause lots of trouble to our dear ones. And Sumita says exactly, that's the main thing. And then I said, look, nowadays there are lots of aggressive treatment for cancer. You might be bedridden, but still you'll be able to function. Your thoughts, you can still think. So we parted on that note. But a month later, Rajoshi called and he said that Sumita told before going that informed these people, and he informed me. I was grateful for that. But it also brought back all the nice memories. In the structural geology, the conference we had in Banaras, I and Sumit shared the same room in Renukot. So every morning he had a big need. For every morning he needed 2 liters, a 2 liter bottle full of water. So I went to the hotel and I saw, okay, they had a, RO system and we could buy bottle of water. So I brought it and he just drank the whole thing. I said, why you do that? He said, that's some kind of a Japanese, treatment. And I said, okay, I left it at that. We talked about various things. Remember, one of the things I want to talk to you all about is, apart from a very good structural geologist, he was you all know he was a wonderful person, and he had a very sharp brain. You all know about that Albright line, and you know that it's found a major uranium deposit that the Uranium Corporation of India is mining that. But the way he found it, he said in the field, remember, like in 60s or 70s, he was in the field in Rajasthan and he suspected that these might be radioactive ore minerals. But how to find it? So he said that he took a shoebox, he went to Udaipur, bought some roll film. Remember those times we used to have celluloid films. Took a shoebox, put the ore inside that, and put black paper all around the box, and also put the film inside. At night within the tent, he opened the reel and put the film inside the box also, so that no light can touch it. And then after 1 day or 2 days, he took it to Udaipur and then got the film developed. And of course, all along the film, there are like pinpricks of light that was from the radioactive minerals, and that had exposed the film. So this kind of innovation, I mean, my hats off to that someone in the field in remote area of Rajasthan without any without Geiger counter, without anything, he would find out a uranium deposit just like that. The last time I went there, he gave me, we talked about his work in Bhutan. He talked about Jangpangi also. That's another thing in him. Whoever, he always used to, talk about people who had worked before him. So he was praising Jangpangi's field work in Bhutan a lot. And then he gave me his papers. He gave me this book also. I don't know if you guys can see it or not. It's on structural geometry of mobile belts of the Indian subcontinent. He said you take it and read it. And remember in that paper, in the talk that was organized by Structural Geology Group, I had proposed that the Himalaya ends somewhere in eastern Bhutan, and all the rocks that we see in Arunachal and all those areas, those are continuation of Eastern Ghat belt, maybe part of Chota Nagpur belt and the Shillong Plateau. Those rocks are continuing in the Arunachal. And remember that talk, I had a 1 hour talk, and that we had a 1 hour discussion in which Sumit took part. And he said, yes, he very much agrees to that idea that Himalaya possibly ends that. And he talked about his work in the Bhutan, where there's a number of thrust planes, and he said possibly that's where the boundary exists. So now that he's gone, now I'll have no one to go to Calcutta and talk about, sound off all these ideas. But I'll remember his mentoring and the example that he has set before us. We know that we all have to go, but hopefully we all can leave something that others can also on that one.
Thank you, Neptunda. How? Can you hear me? Anybody?
Yes, sir. Yes, sir.
Thank you, Neptunda, for sharing your thoughts about Sumitda's association. But don't worry, we are there, and we'll talk about Sumitda also when you will come to Kolkata. Don't worry with that. So, thank you very much.
I'm looking forward.
Yeah, sure. So the thing is, I remember when I was a doctoral student at Jadavpur University, Kolkata, Sumitda used to come to Professor S.K. Ghosh's room, and in fact, he used to talk only to Professor Ghosh, what I remember right now, and in that room, Professor Shrivita Sengupta used to be there. So generally, I found them talking and discussing things. So we hardly discussed anything when we were a doctoral student. Maybe Professor Nibir Mondal, we call Nibirda, is here. Nibirda may have a chance to interact with him in his during his doctoral research time. So I will request first Professor Nibir Mondal to talk something about Sumitda. Nibirda, please. Professor Nivin Mondal is here.
Yes, I can hear you, Shantanu.
Yeah.
May I request Professor Sudipta Sengupta or Sudipta Di to
Okay.
first speak on?
Okay, sure. I thought Shivta Gupta will end the meeting today. So anyway,
Let us hear from the senior people, because
Okay.
they had more,
Association.
deeper observations, wider observations. So
Okay.
we can enjoy listening to them.
Thank you, Nivita. Yes, Professor Shivta Gupta, madam, please, if you are here.
Thank you, Shantanu. Excuse my voice, as usual. I know Shumida from 1962. He was just 2 years senior to me. When I joined Jadavpur University first year geology, within few weeks, we heard about someone very brilliant student, Sumit Ray, who was every professor used to praise him. I mean, it's not that every year there is a first boy, so he's very good. Sumita was sort of best of the best kind of student. Everyone used to praise him. So he was our hero in that sense when we were students. Fortunately, I also chose structural geology, and Sumita, perhaps I was influenced by Sumita because Sumita before me chose structural geology, and that time Subir Ghosh was in Sweden. So Subir Babu suggested him to work with Professor Naha. And that way, and then after 2 years, I also joined. Subir Babu returned from Sweden, and I joined Subir Babu's lab as a PhD student. And since then, I think I not only learned from Subir Babu, but also from Professor Naha also, as he used to visit our lab very frequently. And later on, Sumita also used to visit our lab very frequently to discuss with Shubit Babu. So I have learned a lot of things from these discussions of stalwarts. And sometimes they won't agree. And later on, I also graduated to join in the discussions, and our views will not be same. We'll discuss and try to convince about our own view to each other. So it was and naturally, if you know Dr. Naha closely, he will always what do you call, brighten up the discussion with lots of anecdotes from fields, with not only with Shubir Babu or Shumida or but with lots of other students also. So it was really a very, very enjoyable time when they used to come, either Sumita alone or Professor Naha or both of them together. So I will always cherish those moments. It is difficult for me to imagine that Sumita is no more, because I only learned about his illness just a few days before he passed away, and it still did not sink in. Anyway, I wish Sumita, Professor Naha, Shubir Babu are happy over there discussing a lot of things, and we will join them. Thank you.
Thank you, madam. So with this, another thing I just remember now, because in every 2 years we generally hold reunion meeting at Jadavpur University, and I never found that Sumita is missing there. He is always there, and you'll be happy to know that. I think many people knows it, that Sumit is the last person to leave the campus. When after he'll supervise if every students really had their food and all, and after that he used to leave the campus. He used to love Jadavpur University like his home. So, and the last time I met in during this Bhopal RDS, and that time also he wanted to go to field work, and probably that is the first time I asked Sumit, then rather I told Sumit something that he agreed upon just instantly, that I asked Sumit, please do not go to field work this time. I think it is better for you to take rest for 2 days, and after they will come back from field, you will also start your journey for Kolkata. And at the same time, when Neptunda was saying that he never used a luxurious life, probably Neptunda or Dilipda was saying like that. And here I think I want to say this because I have seen this thing. We have already we had several meeting of RDS in several places. Everywhere he was present, and everywhere he used to go by train. And in fact, I told this thing to his son Rajeshri when I went to their home to see Sumita for the last time when he was really sleeping very nicely there. So this is what I wanted to say. So now I will request Professor Nibin Mondal if you want to say something about Sumita's association with you.
Thank you, Shantanu. It is really very painful moment for me to speak on a person whom I had a huge respect. When I learned this news, suddenly it was really a rude shock. And I had developed two full reactions. In one end, I started thinking that I am eroding my ambience very fast. That such a wonderful personality, when I used to meet him with an excellent, heavenly smile, he used to say, "Nigir kamon acho? How is your work going on?" So this is the kind of personality, modest personality, smooth personality, full of goodness. What way I'm going to get in the coming years? And we had already lost a few more in the recent years. So this is how my mind became quite heavy. And the second full reactions was about the geoscience community, particularly the structural geology community in India. If we look back in the last 3-4 years, we have lost so many not only nice people, but also wonderfully effective people who used to guide us, who used to save us, who used to develop some vision about Indian structural geology. Like Dilipta, now Abhinavada is not also in a very working condition. So this is how structural geology in India is eroding so fast. That makes me quite worried. And Sumit, I worked with him for WAST, Regional Academy of Science and Technology. We used to handle the sectional committee. Sumit was also there. So it was such a nice, ambience that I had. So I was thinking that what way we can lose this kind of personality, and what way we are going to preserve the ambience for this structural geology. So I think at the end that we need to follow the ideology developed by a person like Dr. Sumit Kumar Ray, the modest, goodness. These are the qualities I think we should bear in order to keep Indian structural geology healthy, friendly, and prosper. So with these few words, I sincerely convey my pranam to Sumita, and at the same time, I feel very sad whenever I remember when I was looking at the photo that Sayandev sent, that I'm not going to see this face once again. That's a really very, a painful feeling in mind. So thank you so much.
True, 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 Nirva, true. This is really, you have rightly pointed out the thing that we should follow the legacy that these people have built up. Thank you very much, Nivita, for your deliberation. Now I will request if anyone wants to speak uh, in this forum. I know that Shantanu has raised his hand. Yes, Shantanu.
Hello everyone. Yeah, I don't have that much association like all who spoke, but I mostly used to see him physically in the RDS conferences since 2016, and he didn't miss a single RDS actually. And of course, sometimes I used to talk to him over phone to know something. Particularly some of the work that Anupam described in this direction. So, to know about Indian geology, he was the person I used to call, other than some here, and of course Avinabuddha. Now, what I would like to say about Sumitra is very straightforward. That the way he used to present, in fact, his last presentation in the tsunami in the local RDS, that it's essentially based on observation and his theoretical understanding of the subject. And it's also important to highlight that particularly last two talks I heard from him in two successive RDSs. One is this inversion, called hinge inversion, and the tsunami. He never compromised with some random ideas. He had ideas, but he complemented it with the observations. And that is something I learned from him, and doesn't matter who talks about in whichever way, he always felt strong on his stand. And that's something I learned, and I'll carry this with me, this lesson all over. I'll miss certainly Sumitra in the next conference. It will be a big vacuum for all of us. And on a lighter note, this time, I don't know, probably Anupam Chattopadhyay was there. He was talking about his Maruti car, which is of 1982 model. And whenever he used to take it to the petrol pump to fuel it, the pump owner used to say that you sell it, and Sumitra said, "No, this will stay with me." And he also commented that he's the only one who could drive the car. So, as everyone said, rest in peace, Sumitra. I also feel sad for the car. We will miss the touch of Sumitra, who still used to drive, loves to drive a lot, and so do I. So I feel for the car as well. So like all of us, I'm also feeling sad for the car. Thank you very much.
Thank you, Shantanu. Thank you, Shantanu. Yes, Niranjan. Professor Niranjan.
Yeah, yes, am I audible? This connection, I'm in field. This connection is a little bit
fine. Fine, it's fine. Go ahead.
So when I came to Presidency College, was transferred to Presidency College. Soon after, Professor Sumit Kumar Ray joined Presidency College with his projects, and We had a long association with him as young faculty of the department working in structural geology. I remember that in at least two of the field trips in Rajasthan, where we used to take students to Rajasthan, he would help us in logistics, help us getting into the AMD, and I saw a profound regard of AMD people towards Shumita. I could see that when Shumita was with us, we could approach every place and all the AMD people would flock together and listen to what Shumita used to say. So he took us to many places in Rajasthan, showing us this albitite line, and then to Srinagar. My work in Srinagar actually stems from Shumita's initiative. So he was a wonderful person. I mean, when I was a student, I knew the name Sumit Kumar Ray, read his papers definitely, knew he was in Geological Survey of India, never got the chance to meet him. And when you have read somebody's paper, known that original ideas, very elegant original ideas being published, and then suddenly you meet a man of this stature, it's a very overwhelming experience. But the man himself was so modest, as all of you have said. We didn't, I mean, he was so approachable. We didn't feel that he was a man of such stature. And gradually, Dr. Sumit Kumar Ray gradually became Shumitda. We had the liberty to call him Shumitda. He never objected. When I was out of the department for some administrative job, Shumitda used to come to the department, and then if I had the chance to come to the department, he would call me into his very small room. I can tell you, most of us would not be happy with a room of Shumitda's room. Shumitda's room was about 3 feet by 6 feet room that was given to Shumitda. And at the end, fag end, he had to share it with one of our faculty because we had a crunch of space. But this person was never complaining. I have seen many people fight for rooms and spaces and labs, but he would gladly accept what he was given with. And he would call me into that small room where hardly you could fit one chair, and he would talk with me. He would question me about what am I doing in administration and what are the problems. He had a huge administrative experience, and then when we used to discuss, apart from structural geology, the earlier part of my career, but that part too also enriched me. So personally, I really feel I'm indebted to Shumitda on many counts, and our department, Presidency College, had a legacy of structural geologists, that's true, but inclusion of Shumitda, his presence, and in the formative stages of the university when he was there for 4 or 5 years, that really has helped our department a lot. We from the department are indebted to his contribution. So when we heard that Shumitda is ill and that is an illness which will not bring him back, we really felt very sad, and it was very painful to see Shumitda lying there almost still in a casket. It was really very painful. I mean, the sight I would not like to see, but we went there to see him for the last time. Yes, we will all miss him, and my condolences, deepest condolences to the family, and we will surely remember what he had done, and this elegance of very basic structural geology, the elementary thinking of structural geology, which has really faded out in recent times, needs to be preserved. And Shumitda was something like a huge tree covering all of us. The tree is no more, but there are plenty of senior people in this group, and I'm sure there are very good young researchers in this group. We will all carry this legacy forward. My condolences to the family once again. Thank you.
Thank you, Niranjan sir.
Is there
Any other
anyone,
members of this group? Yeah.
is there anyone from GSI, his colleagues? I saw, I think Prasoon Partho was there, but I think he has left. Prasoon Jana, Prasoon, are you there still? No, I think he has left. Otherwise, they could have.
Dr. Guho was there. Dr.
Guhoda? Guhoda is also. No, Dr. Guha is there.
Yeah.
I'm still, yes.
Guhoda,
I'm listening to everybody very silently.
yeah, if you kindly speak something about your colleague in GSI perspective, you know better than us.
GSI perspective in the sense I joined this organization in '84, and then after training I joined a division together with Sumit in 1987, and I had been given the task of working in the sand mata granulites. So obviously this was a very tough area structurally and even from petrological point of view. So the only thing I had a respite in my mind that whenever I had any questions regarding or queries of the field observations I would make, like specifically for the structural part, he was the only man to answer all those things. This way I could become a very younger colleague and good friend of Sumit. Afterwards, of course, we had grown into such a bond that whenever he used to come to Jaipur, he will certainly call me. And I would also I always loved to meet him. Finally, it became a bond of a sort of a younger brother and older brother. In Khetri also I worked, and regarding those albitite lines and other things, I also had some ideas, similar rock types found in Nathdwara area, where I published a small paper. He even used to read those things very meticulously and question me. And then he was doing all the jobs for the albitite line. And in the last stage now, and after retirement, I also retired in 2017, and he retired much more before me. He is 12 years senior to me by age. He used to often talk to me on phone, and I also used to talk to him maybe once or twice in 1 month or 2 months, just a casual talk, then some other talks also. He was very spiritual man also. And we used to talk about my spiritual teacher, who actually, Dhananjay Das Kathia Babaji, and because my spiritual guru belonged to Bakura, and he also happened to from that place, so he used to talk to me in that line also, much more. And regarding these geological perspectives, I don't know how he could, because he was a very choosy person I knew. He would not talk to anybody and everybody on geology subject unless possibly he thought that he is of a particular standard. It is it's a thing which, because of maybe the reason that my thesis guide was Professor K. Naha, not guide, he was the examiner of my thesis, which I did in 1985. And when he knew that Professor Nahas had interviewed me and he has passed my thesis, he possibly has thought that maybe some metal is there in this boy. Maybe it is his thought. I'm just talking on that thing. And he was very happy to talk to me, and I also felt very much intimately with him all the time, be it in discussions of the structural geological parts of the granulites and other Aravalli fold belts I had been working, or otherwise also the general talks. And lastly, when I talked, just rang up very, as usual, I used to ring him up after maybe 1 month or 2 months sometimes and talk to him at length, half an hour, maybe sometimes 1 hour. I found that he is not picking up the phone. I rang up twice, thrice, then I sent a message. No reply. Then again, next day I rang up. I had some intuition that something wrong has happened. I never knew that he is ill very much. Then next day somehow he started speaking up, but his voice was not, I was not able to understand what he is speaking because the sound was not there in his vocal cord. Then I suggested him that please don't talk much. I will ask anything in message and please go to the ENT and show that if it is phalangitis or something. I never knew that it is a cancer. Then afterwards, within a few days, again I picked up the phone, and then Gaudi picked up the phone and she talked and she said this is the matter. Fortunately, I had an occasion to visit Kolkata on the last week of, on the third week of January, and I met him at his home on 24th of January, and that found that is a really very, for me it was painful, but I never expressed openly with the Gaudi and the sons. He had given me a job to do, finish a write-up and submit it to the Geological Survey, which I will regret that I could not submit before he was here, before his demise, because I came back to Jaipur on 8th of February, and I had finished most of his work and taken the latest data from his son through his computer. Then I tried very fast with the younger colleague Sandeep Nyogi, who is in Agartala, and finally I made a target of submitting that thing because almost finished. I had almost finished the work. I targeted to finish it up because I had the news that there is a time is very short. His son had actually messaged me on 8th. But unfortunately, I could not tell him that I have done your job. And I submitted that paper on 14th. When I met him at his house on 24th of January, he was so happy to see me and my wife. And he talked about all the geological parts of the albitite line, and the paper is related with that albitite line only, and the sulfide nodules having the gold, silver and PG minerals within it, and the pyroxenite albitite, this felsic and mafic type of cumulate formations, and the other geological and structural inputs into it. He tried to tell me how to modify the things and do the job very fast. He had actually requested through Sandeep Nyogi that if I am willing to see these things and modify the things as per the publication yardstick, you do it. Then I took this responsibility, and I am happy that I have at least submitted this thing as he desired. And this paper is in his name only. He is the first author. As usual, he was there in the authorship. So I was very sad for me actually. I never thought that this will happen so fast. Unfortunately, we have all to go away sometime, but his legacy will remain. And this is a very nice paper he had prepared, which I modified and here and there edited a little bit, put the ideas which he had told me while in the last stage of his days, actually last stage. It was very interesting to tell that, it is very interesting to tell that he never talked about his illness. He talked about the geology at that moment itself, when he is unable to speak up. And I could hardly very carefully listen to his things that check those shear zones and the albitite occurrences among those, and how to modify the things. He just told me many things which I remembered to, and
and I just did the job he desired. But I had an idea that let me do the job before he, because I could understand that he'll be there for not very longer time. Unfortunately, I could not tell him before he went away. This is what is my feeling, and he will always be remembered by me and even my family. He used to love my wife also, and that as a very, very younger brother, I would say. And I also used to love him because he was such a genius man. Whatever I had a query, he was the only person to answer from the structural geology point of view. This is what my homage to him, his family, Rajarshi, Bodhi, and others. Let peace be there. Thank you very much.
Thank you. Shandip, are you there?
Yes, sir. Yeah.
So, if just make us we can make an open request if anyone else wants to speak.
Yeah.
Or else we can conclude, I think.
Yes, sir.
Yeah.
Sir, please go ahead, sir.
I would suggest that following Anupam's tribute to Sumita, that if we can make a list of Sumita's publications and just mail it through our whatever channel we have, this will be very useful for junior people, the younger people, because you all know about his contributions, but some of our younger colleagues, they'll be influenced or they will learn from the publications of Sumit Ray. That's my request.
Yeah, I think Dilipda, I have more or less all his major papers with me, and I can share it with either Shantanu or Shandip, who can put it on. I do not know how to put this in the SGTSGI channel, in which form it will be best. I can share with you, or if you suggest me, I can directly share on any platform, because I have mostly his papers, although maybe one or two GSI smaller GSI inside publications may be missing, but he has major papers, 4 papers in Journal of Structural Geology, 3 in Tectonophysics, 1 in Sedimentary Geology, 1 in Precambrian Research, 4 in Geological Society, Current Science, and all very contribution to Mineralogy, Petrology, American Journal of Science. All those papers are available, and I have collected those things, so I can share if necessary, or we can give the links to others. That is possible.
So my suggestion would be to send the link of the Google Drive to share. You can share this Google Drive link with Shandip, and Shandip will upload the thing.
Okay, no problem. Okay.
Shandip, is it okay for you?
Right, sir. Yes, sir. Yes, sir. No problem, sir.
Okay.
I'll calculate the drive.
I'll share it.
Drive link.
Fine. No
Yeah.
Okay. So if there is no more, if there is no one to share any thought, I understand that this is not the time to really talk about the person whom you love and whom you like most. So with a good note, I think we should conclude, and we know that Sumita will remain with us forever, and we'll keep remembering him at least in every RDS for sure, and he will be with us, and he is with us, in fact. His work will be with us, and his work will inspire most of us, and we'll build things from the legacy of the this experienced people that Professor Nibir Mondal has talked about, to build the next community of structural geology in India. With this note, I think we can conclude here.
Yes, sir. Yeah.
Sumita, we all love you, Sumita.
Thank you all for joining.
Okay, see you all Om Shanti.
Bye, everyone.
Goodbye.
Om Shanti. Bye.
Sudeep, please raise a hand.
Madam, you want to talk something?
No, I just wrongly pressed that. I wanted to say goodbye to everyone. And
Goodbye.
I just remember Shumita. It still feels strange to talk in past tense that he is no more.
Yeah,
Anyway,
that's so true.
you have to accept that. Goodbye. Goodbye.
Goodbye. Bye.
Bye-bye.
Bye.